Graphing linear equations using intercepts and then also using slope intercepts. First of all, let's define an intercept. That is where a line crosses or intercepts. Same thing, that's why I use that term, crosses or intercepts the x-axis. So it crosses the x at some point, and it's not going up or down at all. So the ordered pair will always have a 0. Okay, so to find the x-intercept, we plug 0 in for y, because y has to be 0. If it's crossing the x-axis, let's say at this point, over 2 up 0, if it's going to be on the x-axis, the y-coordinate's always going to have to be 0. So if I want to know where it is exactly crossing the x, then I know that the y-coordinate at that point has to be 0. So instead of saying when x is 2, y is 0, I'm going to do that process backwards. And I'm going to plug 0 in for y, and I'm going to solve to figure out what the x value is. So plug 0 in for y. That's to get the x-axis. Okay? To solve for x. Vice versa, the y-intercept is where the line intercepts the y-axis. Okay, so now the y is going to be where it's crossing. The x value is going to be 0. Just as though it were here, let's say 0 up 1. The x-coordinate is always 0 if it's on the y-axis. So to find the y-intercept, plug 0 in for x to solve for y. So they're backwards, they're counterintuitive. Let's practice that. So we're going to find the intercepts for this equation. Where does that equation cross the x-axis? Where does it cross the y-axis? So if I'm looking for the x-intercept, I'm going to plug 0 in for y. So 3x minus 0 equals 5. And then I have to divide by 3. So the x-intercept is at 5/3. Okay? So crosses at 5/3, 0. That's the x-intercept. For the y-intercept, I'm going to put x in for 0. So same equation, this time I'm just putting 0 in for x. 3 times 0 minus y equals 5. 3 times 0 is 0. Negative y equals 5. And divide the whole equation by negative 1 to change the signs. So my y-intercept is 0, negative 5. Okay? So you're plugging 0 in for y if you're looking for the x-intercept, and you're plugging 0 in for x if you're looking for the y-intercept. It's always backwards. So now we're going to practice. Let's practice doing this. Okay. Graphing linear equations using the intercepts. So let's try it. So again, we have to do this twice, right? So I'm just going to go ahead and write the equation over again. In the first one, I'm going to put 0 in for y. And then I'm going to subtract 3 from both sides. So I get negative 3 equals x. So it crosses the x-axis at negative 3. Okay? And then, so I had 0 in for y. Now I'm going to put 0 in for x. So y equals 0 plus 3. And y equals 3. So it crosses the y-axis at positive 3. And so we're graphing a linear equation. So what we did is we graphed the x-intercept and the y-intercept, and then we're going to draw a line containing both of those points. In other words, we're going to connect the two. And there's your linear equation. I would use a ruler if I were you. I kind of made it a little crooked, but you get the idea. You use those 2 points, you connect them with a ruler, and you've graphed your linear equation. That line crosses the x at negative 3, and it crosses the y at positive 3. Let's check this one. Again, we have to do this twice. Okay? So we don't like fractions, I know. Negative 1/3 times 0 plus y equals -2. The good news here is when you plug 0 in for x, it cancels. Y is -2. So I know it crosses the y at -2. So here's my y-axis, here's -2. And then I'm going to plug 0 in for y. So negative 1/3 x plus 0 equals -2. Okay, so negative 1/3 x equals -2. I'm going to multiply by 3 to get rid of my fraction. If I do that to one side of the equation, I have to do it to the other. So negative x equals -6. Divide the whole thing by -1 to change the signs. X equals +6. So crosses the x at +6. And now I can just connect the two. I'm going to try really hard without a ruler to do this. And get your linear equation. So that's the strategy of using the intercepts. Now you can see that if there's fractions in the equation, sometimes it can get a little tricky. And so sometimes that's not always our favorite strategy. So let's talk about a different strategy for when the intercepts tend to be messy. And that is to solve an equation for y. So we're just going to put it in slope-intercept form, right? That's really what we're doing. If you're solving for y, you're getting it in mx plus b form because we get a lot of information about it that way. First, let's just practice solving an equation for y. Here's the term with the y in it. And then remember that your balance scale has to stay balanced. If you subtract 2x from one side, you have to subtract it from the other. So here's another thing I want you to be thinking about. When you go to rewrite this, put the x term first, always. -2x, that's a +4, so I'm going to write +4. Okay, so I got the term with the y in it all isolated by itself, but the y is still being multiplied by 3. So to undo multiplication, I have to divide every single term. Y equals -2/3 x plus 4/3, or 4/3. So solved it for y. Okay, let's do the second example. Here's the y term. Balance scale. I have to undo -3x, so I'm going to add 3x. If you do it to the left-hand side of the equation, I'm going to do it to the right. My 0 pair cancels. Y equals, again, put the x term first, 3x plus 5. All done. Last one. Here's your y term. Here's your balance scale. If you subtract 6 on the left, you need to subtract 6 on the right. 2y equals, these are not like terms because that 6 does not have an x, so I'm just going to put my x term first. -4x minus 6. The term with the y in it is all isolated, but the y itself is still being multiplied by 2, so I need to divide every term by 2. And lucky for us, they're all divisible by 2, which means I get rid of all my fractions. And so my equation is much simpler. So that was just a review of how to isolate the y term. Okay. Now we're going to put that into practice. We're going to use that strategy to help us graph lines in slope-intercept form. So we're going to do these two examples. First, solve the equation for y. So lucky for us, done. Y equals 2x plus 5 is already all solved. Identify the y-intercept. So this term at the end is always the intercept. That means it crosses the y-axis at +5. Okay? From the intercept, demonstrate the slope at least twice. So I have to do the slope from that point twice. The slope is the number in front of the x. It's a whole number, which means I can put it over 1. And since it's a +2, it means that I'm going to rise 2 and run 1. Because remember, slope is rise over run. And we always run that way because that's the way we read. So I'm going to go up 2, rise 2, and run 1. Rise 2, run 1. So there's the equation. And I'm just going to use a ruler, I hope. I'm just freehanding it. Use a ruler and connect those. So notice I did that at least a couple of times. So there's my line. Again, solve the equation for y, and again for s. This one's already done. Okay. And my y-intercept is -3. It's always the number at the end, so it crosses at -3. There's my intercept. And the slope is -1/3. So if the slope is negative, that means I'm going to fall. And I remember this is my rise. So since it's negative, I'm going down 1, fall 1, and I'm always, this is always that way. Run 3. So down 1, run 3. Down 1, run 3. And we're going to have a conversation about slope soon, and so we'll do a little more practice with this. So we're going to, it's negative, so we're going to go down 1 and run 1, 2, 3. Down 1 and run 1, 2, 3. Do it again. Down 1 and run 1, 2, 3. And so I would agree that that line is going down 1 and running 3. So it has a slope of -1/3. And so use a ruler and go ahead and connect those. There's your linear equation.